Okay, so this is a parallel circuit. I can tell this is a parallel circuit because a parallel circuit has more than one pathway for electrons in which to travel. We have, again, a 12-volt battery, and we have two 10-ohm resistors. And these, again, are in parallel. And I know that because when I get to this juncture, assuming I start this way from the battery, which I can assume, at least for now, it doesn't really matter if I want to go the other way, it'll just be on the other side of the diagram, that the electrons have a choice of which path to take. So that makes this a parallel circuit. When we go to solve this circuit, one of the first things, of course, we always do is to find the total resistance of the circuit. To do that, we have to use an inverse relationship that exists within a parallel circuit and the branches of a parallel circuit. 1 over RT equals 1 over the resistance of the first resistor plus 1 over the resistance of the second. So, luckily, I chose something with the same resistor, so my common denominators are easy. Otherwise, we would use the inverse button. This, remember, is equal to 1 over RT. I'm going to flip that around to get RT, and then do a little math, and I get 5 ohms. So what you'll notice is that my total resistance drops even though I have the same resistors as the previous problem. That's because they're in parallel. Once I find the total resistance of 5 ohms, I'm going to find the total current, just like I did before. I'm going to use Ohm's law to do it. Voltage divided by resistance equals current. My voltage is 12. My resistance is 5. That makes my current approximately 2.4 amps. Hopefully you can see that. Now, once I find this, I want to decide, or I want to discover the voltage change as well as the current change across each of the resistors. The rules for a parallel circuit are pretty much the opposite of a series circuit. In a series circuit, the amps remain the same, the current remains the same across every resistor, and the voltage splits. And the opposite is true in a parallel circuit. So what I mean by that is that the volts remain the same and the current will split in a parallel circuit. So if I have a 12-volt battery down here, each of these resistors is getting the full 12 volts right across it. It means your battery is going to drain a lot faster, but it also means that now I need to calculate my current. Hopefully you've predicted by now that the current, if it's going to split, should split equally because I have equal branches. But let's show it. V on R equals I. I'm going to take my 12 volts of push and I'm going to divide by my 10 ohms of resistance, get 1.2 amps, which, as you'll notice, is half of 2.4. Same math would go for the second resistor, so I'm not going to redo it. And I have 1.2 amps in that second resistor. So that would be how we would solve our parallel circuit. Next, we're going to do a combination.